Okay, so let's look. We have a 4x squared, a 4x squared y cubed, and we have a 6x to the fourth y to the fifth. So we're going to find the least common multiple. And when we're talking about that least common multiple, what are we really looking for? We're looking for that common denominator. And so we'll break it up, okay, just like we did on the little handout. We're going to look at the 4 and the 6. What would their least common multiple be? Be what? No, they're multiple. They're multiple. I know it's y'all. 12. Yes. So between a 4 and a 6, they would both be represented with a 12, right? Because that would be your 4 times 3 and your 6 times 2. Now, let's look at the x's. All right, you have an x squared. That means you have how many x's? 2. You have an x to the fourth. That means you have how many x's? 4. So to represent all the x's, how many would we need? We would only need the 4. Very good. Because when I use my x to the fourth, are these two still represented? Yes. Yes. So that will pull them both in. Okay? And then do your y's. I have a y to the third, so that's how many y's? And I have a y to the fifth, that's how many y's? 5. So to represent all the y's, I would need how many? I would need, I would only need 5. Preston?
You said you follow your lectures online, right? So if I wanted to watch last, well, not last class, but the class before, I could watch it online?
Okay. So essentially, what did we do? We split them all up. We used our 4 and our 6 to get the 12. We had an x squared and an x to the fourth, so we have to take the highest power here. And then we had y cubed, y fifth, and we took that highest power there. So this then would be considered your common denominator for these two. You would think of these as denominators, and this would represent them both. Okay? All right, let's look at B. All right, what would you do with an x squared minus 2x minus 3? Yes. Would you use your x method? Yes, you would. See how all this is coming back? We're still using everything we've been doing. All right, let's do that. Okay, so with my x method, I have a negative 3 and a negative 2. So what would that factor into? Negative what? 3 and positive 1. Okay, what can we do with the x squared minus x minus 6? We do the x again. So nothing new. We've been doing this. So we have the negative 6 and a negative 1. So what would that factor into? Negative 3, positive 2. Yeah, I think so. I would agree with that. Okay, so now we're ready. We've factored it out. Now let's find the least common multiple, which essentially is that common denominator. So I have an x minus 3, so I'm going to represent him as an x minus 3. I have an x plus 1. How are we going to represent him? X plus 1. Okay, so he's taken care of. I have an x minus 3. I already have an x minus 3, so I'm good, right? He's already represented. I have an x plus 2, so what do I need to represent an x plus 2? X plus 2. Okay. So that would be my least common multiple / common denominator. I would need to have all of those. Again, you do not have to repeat. If you have a binomial already in the common denominator, you do not have to repeat it. Okay? Questions on that one? Okay. Okay. So the x squared plus 3x minus 4, we are going to use our, going to use that x method. Negative 4 and 3, what's that going to factor into? Positive 4 and negative 1. Thank you. Okay. The x plus 4 in our second rational expression, we cannot do anything with that, right? Okay, so let's come over here. Let's go ahead and find our common denominator. X plus 4, I will have to represent him just as an x plus 4, right? And by x minus 1, I will have to represent him as an x minus 1. So I'll bring that one over. Okay, your second rational expression. What about this x plus 4? Do I need to bring that over? No, he's already there. So we're good. So here's our common denominator. Okay, so let's go back now and multiply through with any special ones that we need to make them the same so we can add them. All right. So the x minus 3 had a denominator of x plus 4x minus 1. Did it change? Did it change from an x plus 4x minus 1 to an x plus 4x minus 1? No. So if my denominator did not change, is my numerator going to change? No. So bring him on over as is. Okay, your x plus 4. We went from an x plus 4 to an x plus 4x minus 1. What do we need to multiply over here with? The x minus 1. So your special one in this case would be that x minus 1. We've already multiplied the denominator. That's over here. Now do the numerator. What would that give you? 2x? Is that right? 2x squared minus 2x? Okay. All right, so clean it up. Combine like terms. We have a 2x squared. Can we add anything to that one? No. We do have an x and a negative 2x. And minus 3. Over your denominator. We could. You want to try it? Okay, what should jump out at you is that x squared minus 4, difference of 2 squares, so let's factor that. X minus 2, x plus 2. Okay. Our first x plus 2, it cannot be. All right, so let's do common denominator. Well, I know this whole thing needs to be represented, the x minus 2, x plus 2. So let's bring them on over. So that will take care of this one here. All right, what about our x plus 2? Have we represented him? Yeah, he's good to go. He's represented right here. Okay, now let's make this good. Let's get some special ones going here. So let's take a look at the first expression, the x plus 2. The common denominator is an x minus 2 times x plus 2. So what needs to happen to our first term here? Needs to be multiplied by what? X minus 2. So do that. We've already done the denominator because we're already over there. So just the numerator, multiply that out. That's going to give you x squared minus 2x. Yeah, okay. Your second one, you had x minus 2, x plus 2. You still have x minus 2 plus 2. So do we need a special one over here? No. So we'll just bring negative 8 over as is. This one, I think we can do.
Yeah.
Let's try that. You did? Okay, what'd you get?
I got x minus 4 over x minus 2.
Okay. Over our denominator of x minus 2, x plus 2. Yeah, this will work. What can we cancel out? X minus 2's. Like I said, sometimes it works, sometimes it doesn't. Okay, so x minus 2's will go. That would leave us with the x minus 4 over x plus 2. Yeah, that'll work. Done?
Should we always check to see?
Yeah, always check and just kind of do a spot check. Because I kind of looked at this and I knew that I could probably use a 2 and 4, and I kind of noticed I have some 2's down here. So yeah, I would automatically just kind of do a quick check. Okay, let's go back and redo. So I made a mistake. So I have, that's going to factor into x minus 4, x plus 2. All right, now we got it. Okay, so now this time what cancels out? The x plus 2's cancel. Thank you for catching that. Appreciate it. Okay, so now we have left x minus 4 over x minus 2. Now, do you want you to tell me where this one is undefined at? What can x not equal? 2. Anything else?
4.
No. Go back up here. Go back up here before we canceled. Before we canceled, we had x minus 2 and we had x plus 2. It cannot be the 2 because this one would go to 0. It can also not be negative 2. It'll go to 0 there. Go back to before you canceled. Go back to before you canceled. Okay? Okay. Did you do something with the x squared minus 9? Yes. What difference of 2 squares? So factor that. I'm going to go ahead and let the screen do it. Okay. So we're going to take that x squared minus 9. It is a difference of 2 squares. Factor that into the x minus 3 and the x plus 3. And now we're going to decide what we're going to do for a common denominator. Can you tell me what it's going to be?
It's supposed to be
Oops. Hold on, let me back up. Christian, tell me again, what is it going to be?
x plus 3, x minus 2.
Okay, x plus 3, x minus 3. Alrighty. Y'all agree with him? I do. Okay. Alright, so let's go back now. Your first expression, are we going to multiply the numerator 2x squared minus 30 with a special 1? Do we need a special 1 on this one? No, we did not change. So bring it on over. Okay. Now let's look at our second one. All right, guys, here's that negative sign. You have to be real careful. Here's what you're going to do. You're going to put your negative, you're going to put your minus right here in your problem and put a parenthesis right there. Now, we have an x plus 3. What do we need now to make it complete? The x minus 3. So you're going to come up here with that x plus 5, and you're going to multiply it with the x minus 3. Okay? And I'm going to bring that down here. You're going to have to use your FOIL method. So first outer, inner, last. So first, your x times x squared. Your outside, your x and your negative 3, negative 3x. And then your inside, your 5x is 5x. All right, what's a negative 3 and a positive 5x going to give you? 2x. Last, the 5 times the negative 3. Negative 15. Right?
When, the subtraction sign make the 5 a negative?
We haven't done the subtraction sign yet.
Okay.
You're a step ahead of me. We're fixing to get to it. All right. Now, take this x squared minus 2x minus 15, pop it up here. Okay. All right, now. Okay, Christian, this is what you want to do a second ago. Now distribute the negative sign, okay? So the x squared would become negative the 2x would become negative, and the negative 15 would become positive. All right, now, clean it up. Combine any like terms that you have. We do have x squares, so we will start with them first. 2x squared and a negative x squared would give you what? X squared. Do we have any x? I'm going to cancel out so we know what we're doing. The x squareds are out. All right. Do we have an x term? The negative 2x. He's by himself, so he'll come down unchanged. And constants. A negative 30 and a positive 15 would be a negative 15 over the x plus 3, x minus 3. I think this one can also be factored. Okay, so we can take the x squared minus 2x minus 15. We can see that we can factor that, which would then enable us to cancel the x plus 3's, leaving us with the x minus 5 over the x minus 3. And x cannot be, right here, x cannot be a positive 3 or negative 3 because the denominator would go to 0 in either case. I'm going to stop this one. All right, questions on that one? How are we doing on time?